All right, so we're going to start talking about statistics. And if you're a junior, then you get to decide next year what math class to take. And statistics is a class that's offered. It's a really good class. A lot of careers use statistics. So it's something to consider. We are just going to do a teeny tiny bit of statistics the next few days. So if this is something that you feel like like if you like words more than you like numbers, statistics might be something that you would prefer instead of another math class that's offered. So it's up to you. But statistics is a branch of mathematics dealing with the collection, analysis, interpretation, explanation, and presentation of data. Now, like I said, we're only going to talk about statistics for like a week. So we aren't going to get through all of those things. But if you take the year long statistics class, those are all the things that you'll learn. And you have learned some statistics over the years about presenting data and like looking at box plots and all kinds of stuff. But today we're going to focus on the collection of data. So surveys are often conducted to collect data about a population. And then a population is the entire group of people or objects that you want information about. And a census is a survey of the entire population. Now, I think you guys have probably heard of a census before. So every 10 years, the government tries to get information about every single person in the entire country. And so they expect every single person to answer the survey. Now, that's difficult and that's expensive and that's time consuming. So sometimes you don't have the ability to survey every single person in the population that you're studying. And so when that happens, a sample or part of the population is surveyed. All right, and to pick that sample, it's important that you want the choosing of the sample to be random. So if it involves chance, it's considered a random sample or a probability sample. And random samples should be non-biased, which is what you want. You don't want any bias in your data results. So non-random samples can result in a biased sample. And so a couple of examples of biased samples are self-selected samples, which is when people volunteer to participate. And that might be biased because a lot of times when people volunteer to participate in a survey, it's because they have strong feeling for or against whatever is being studied. And so that can like over represent part of that population. And then convenience samples are asking the first people you see. And that's also going to be a biased sample because like the first people you see might be all your friends, and if you're trying to get information about something that's going on, um, all of your friends probably think very similarly, and so you wouldn't get a good idea of what the whole population feels. All right, and a biased sample is a sample that may not be, that may not be representative of a population. And in a biased sample, the population can be underrepresented, which is kind of a weird word. So it's just under and then represented right after it. Or overrepresented. All right. So we're going to look at a situation and we're going to decide if the sampling method could result in a biased sample. So on example 1, the administrators at your school want to know if more vegetarian items should be added to the lunch menu. Decide whether the sampling method could result in a biased sample and explain your reasoning. Okay, so A says that you're going to survey every 10th student waiting in line to purchase lunch. So surveying every 10th student is actually a really good way to do it randomly, but I'm not sure this is exactly the best place to choose every 10th student. Why not? Who doesn't stand in line to purchase lunch? Do you guys all buy school lunch? Did any of you bring your lunch? None of you? All right. My kids did not enjoy cafeteria food, so they always brought their lunch. So this isn't, this would be a biased sample. And it's because the people who bring their lunch might be bringing their lunch because they want vegetables. So those people are underrepresented. So the people who bring their lunch are underrepresented. All right, what about survey every 25th student who enters the cafeteria during their lunch period? What do you think? Is that biased or non-biased? Non-biased. That's a really good way to do that because you get the people who buy lunch and the people who don't buy lunch. It is random. So every 25th person is a random situation and it's representative. That's what you want. Okay. Now, a big part of the lesson today is going to be looking at the differences between experiments and observational studies. So, an experiment imposes a treatment on individuals to collect data on their response to the treatment. So, a treatment could be a medicine, or a treatment could just be, I don't know, a type of food. There's lots of different types of treatments. All right, and then an observational study. An observational study observes individuals and measures variables without controlling the individuals or their environment in any way. So you basically just watch people do what they always do. You don't try to change anything in their situation. All right, so on example 2, we're going to determine whether each situation is an example of an experiment or an observational study. So A says that a researcher asks college students how many hours of sleep they get on average and examines whether the number of hours of sleep affects students' grades. That is exactly what an observational study is. You don't try to tell them to sleep a certain amount of time. You just look at what they're already doing and analyze what's going on. All right. And then B, an employee of the Parks Department wants to know if paint that includes latex is more durable than paint without latex. She has 50 park benches painted with the paint that includes latex and 50 that does not have latex. And eventually I'm sure they compare the results. So what do you think? Experiment. Good. So the treatment she applies is the type of the paint with the latex. All right. All right. So in order for the data that are collected in the experiment to be valid, the experiment must be carefully designed. Now, if you guys have taken psychology before, you might know some of these things that we're going to talk about. So in a controlled experiment, two groups are studied under identical conditions with the exception of one variable, and that variable is the treatment. So on the one we just talked about, the treatment was the paint. So the group under ordinary conditions is the control group. So those would have been the park benches that don't have the latex paint. And then the group that is subjected to the treatment is the treatment group. And that would be, in that previous one, the park benches that do have the latex paint. All right, and we're about to write some kind of long words. So in a randomized comparative experiment, individuals are randomly assigned to the control group and the treatment group. And so you have two different groups, one that's normal, one that has the treatment, but you assign them randomly. That's the best type of experiment you can do. So an experiment that is not randomized comparative experiment may be subject to bias, and any conclusions drawn from the experiment may not be valid. So you can look at the data, but it might not be legitimate study if this doesn't happen. All right. So on example 3, we're going to determine whether the study described in the report at the right is a randomized comparative experiment, and then we're going to talk about the parts of it. So a faster web design. To test the redesign of its website, an online bookseller assembled 96 users of the site and randomly divided them into two groups. One group used the new website to make an online purchase, and one group used the old site to do the same transaction. Users of the new site were able to complete the purchase 22% faster. Okay. So do you guys think that is randomized comparative? Yeah. So because they were randomly divided, and then you have a treatment group and a control group, then yes. Okay, so because that's yes, let's go ahead and talk about what those three things are. The treatment. So the thing that they're studying is the treatment. And so what they're studying is the new website. That's the treatment. Right. And then the treatment group is going to be the users of the new website. And then the control group are going to be the users of the old website. Right. So once you figure out the treatment group, it's easier to know the other two. So whoever has the treatment applied is the treatment group. Okay, and then the last thing we're going to talk about is if you're wanting to study something, should you do an experiment or should you do an observational study? So, randomized comparative experiment should be used to gather data whenever feasible. However, it may be necessary to use an observational study for reasons of practicality or ethics. So if it's not practical for you to be able to do an experiment, you can do an observational study. Or if it's not ethical, and we'll talk about ethical when we do this, I think you'll be able to figure it out. So on example 4, explain whether the following research topic is best addressed through an experiment or an observational study. So A, you want to study the effects of smoking on lung function. So if we think about doing an experiment, if it was a treatment group and a control group, the people in the treatment group, you would need to make them start smoking. Is it ethical to do that? No. So this one would be one that you would want to do by an observational study. It is unethical to impose the treatment of smoking, or it's unethical to make someone start smoking to do your experiment. All right, for B, you want to know if people who consume 1,000 milligrams of vitamin C each day as a dietary supplement have lower cholesterol levels than people who do not. So, would it be unethical for you to ask people to take vitamin C? No, that's not going to harm anybody. So, this one would be experiment. All right, and then C. You want to know if cats that are fed a diet of only canned or soft food experience more dental disease than a cat that is fed a diet of only dry or hard food? Would it be unethical to have cats take something that could cause dental disease? They are cats, but it still would be unethical. So we would do this by an observational study. You would take some cats who only eat soft food and compare their dental health to cats that only eat dry food.
So if there's one that's like you can't really tell if it's observational or experimental.
I think you should be able to. If you just ask yourself, like, ethics. If you're testing to see if something is harmful, then you would probably always want to do an observational study.
You might not test on it. Maybe wording things.
You're right. It can get tricky. And then the smoking one. So you would do an observational study. You would study the lung function of people who smoke compared to people who don't smoke. Yeah. All right. So I'm going to give you your assignment. It's no calculations. It's all words. You may or may not like that. I don't know.